Hello friends, this is a crash program for Neet and JEE, and the first unit that we are going to discuss is physical world and units and measurement. In physical world, this is just an introduction to higher secondary physics. The point that we have to study is what are the fundamental or basic forces in nature. Fundamental or basic forces in nature. Okay, there are four basic forces. They are strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. Okay. These I wrote in decreasing order of their strength. Strong nuclear force is the strongest, and gravitational force is the weakest, and this is the decreasing order of their strength. So when we are comparing their strengths, if you are taking strength of strong nuclear force as 1, then electromagnetic force has strength 10 power minus 2, weak nuclear force has strength 10 power minus 13, and gravitational force have strength 10 power minus 39. That means strength of electromagnetic force is 10 power minus 2 times the strength of strong nuclear force. Or we can say strength of strong nuclear force is 100 times than electromagnetic force. We know that nuclear forces act inside the nucleus. So nuclear forces are short range forces. Nuclear forces are short range forces. Strong nuclear forces have a range 10 power minus 15 meter, and weak nuclear force has strength 10 power minus 16 meter. Electromagnetic force and gravitational force are long range forces, and they are conservative forces. Electromagnetic force and gravitational force are conservative forces because mechanical energy will not get lost in the form of heat, sound, etc. But nuclear forces can be converted into or converts into sound, heat, etc. We already studied nuclear fission and nuclear fusion. And strong nuclear force and weak nuclear force are non-conservative forces. Okay, now what is a unit? Unit is a standard reference, internationally accepted standard reference used to represent a physical quantity. For example, if length is taken as a physical quantity, length equal to 1 meter, that is equal to 100 centimeter. Length is the quantity and 1 is the numerical value, meter is the unit. Okay, so meter and here centimeter is the unit. These are the internationally accepted standard references. They are used to represent the physical quantity length. So every physical quantity we can write Q equal to Nu. Q equal to NUN is the numerical value and U is the unit. So we can say here 1 meter equal to 100 centimeter. Like that we can say N1 U1 equal to N2 U2. N1 U1 equal to N2 U2, or N2 by N1 equal to N2 by N1 equal to U1 by U2. N2 by N1 equal to U1 by U2. This is called a conversion factor. This is called a conversion factor. When we are converting N2 is the numerical value in second system, N1 is the numerical value in first system, U1 is the unit in first system, and U2 is the unit in the second system. So N2 equal to, we can write N2 equal to, we can write N1 U1, N1 U1 by U2, N1 U1 by U2, or N2 equal to N1 into M1 by M2 all power A, L1 by L2 all power B, T1 by T2 all power C. This equation is used to convert unit from one system to a second system. N2 equal to N1 into M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. What are A, B, C? They are the powers of mass, length, time in dimensional formula of the physical quantity. This equation is used to convert units from one system to another system. Okay. M1, L1, T1 units of mass, length, time in first system. M2, L2, T2 units of mass, length, time in second system. N2 numerical value in second system. N1 is the numerical value in first system. This is the question. Suppose in a new system, unit of mass is 100 kilogram, unit of mass is 100 kilogram, unit of length is 1 kilometer, and unit of time is 100 seconds. And call the unit of energy ELOJ. What is ELOJ? Joule is wrote in reverse order. Joule is wrote in reverse order. ELUOJ. Then 1 ELOJ equal to 10 power 4 joule, 1 ELOJ equal to 10 power minus 3 joule, 1 ELOJ equal to 10 power minus 4 joule, 1 ELOJ equal to 10 power 3 joule. What is the answer? How can we find the answer using that equation? In all options we can see 1 ELOJ equal to. So 1 ELOJ equal to 1 is the numerical value in first system. So we are converting from the new system to SI system. From the new system to SI system. Okay, we have to find 10 power 4 joule or 10 power minus 3 joule, 10 power 3 joule or 10 power minus 4 joule. So 1 ELOJ, 1 is the numerical value in first system. We don't know what is the numerical value in second system, in the SI system. N2 we have to calculate. And here it is energy, unit of energy. So we have to get ABC. Dimensional formula of energy is same as dimensional formula of work, that is force into displacement dimensional formula ml square t power minus 2. So we will get A equal to 1, B equal to 2, C equal to minus 2. So to find N2, we have to use that equation. N2 equal to N1 into M1 by M2 power A, L1 by L2 power B, and T1 by T2 power C. This is our formula. Okay, what is N1? N1 is 1. M1, unit of mass in first system. Unit of mass in first system is 100 kilogram. By M2, unit of mass in second system. In second system, unit of energy it is joule. So it is SI system. In SI system, unit of mass is kilogram. And A is 1. All power 1. And L1, unit of length in first system is 1 kilometer. 1 kilometer divided by unit of length in second system, that is SI system, it is meter square all raised to 2. And unit of time in first system is 100 seconds divided by unit of time in SI system, second system it is second all power minus 2. Then we will get kilogram cancelled, meter cancelled, second cancelled. 100 is 10 square. Here kilo is here, right? So 10 raised to 3 all square. In here 100 is 10 square all raised to minus 2. So we will get 10 square into 10 power 6 into 10 power minus 4. 10 power 8 into 10 power minus 4, it is 10 power 4. So our option 1 is the right answer. Option 1 is the right answer. So when we are using this equation, we have to confirm from word to word what is the first unit, first system, and what is the second system. That we have to understand from word to word we are calculating, from word to word we are converting when we are using this equation. Now SI prefix. SI prefix means powers of 10. Okay. Normally we use powers of 10 while writing numerical value of a quantity, like that 10 power 6 is mega. We will write with the letter capital M. Mega is also called million. Like that 10 power 9 it is giga. Capital M, it is called billion. 10 power 12 is tera, capital T, it is also called trillion. 10 power minus 6 is micro. The symbol is mu. 10 power minus 9 is called nano, small n is the symbol. 10 power minus 12 is called pico, small p. Like that, we have lots of SI prefixes to study. One micron is 10 power minus 6 meter. 1 micron is 10 power minus 6 meter, that is 1 micrometer. 1 micrometer. Micro is the SI prefix that we can use along with any numerical value, but micron is not SI prefix. Micron is unit of length because meter is hidden inside it. So micron is not prefix, micro is prefix. Micron is a special name given to 1 micrometer only. Okay, micron is not 1 microsecond. Micron is 1 micrometer unit of length. But we can say microsecond, microgram, micro hertz, etc. But micron is not like that. Micron is 10 power minus 6 meter or 1 micrometer, like that. There is one more, 1 Fermi. Fermi is 10 power minus 15 meter or 1 femtometer, 1 FM. So Fermi is a special unit of length. Fermi is a special unit of length. Like that we can say light year. 1 light year. Light year is unit of length, distance traveled by light in 1 year through vacuum. Its value is 9.46 into 10 power 15 meter. Light year is unit of length, not unit of time. But you studied, you heard that tropical year. What is tropical year? Tropical year is 365.25 days. Tropical year is unit of time. It indicates the time taken for one revolution of Earth around the sun. And what is one common year? One common year is one calendar year. It is 365 days. And one more thing, one leap year. We know that 2020 is a leap year. Leap year means it contains 366 days. 366 days. Then you can expect a question that select the odd one. Light year, tropical year, common year, leap year. Which is the odd one? Light year is the odd one because it represents unit of length, and all other 3 years are tropical year, common year, leap year. They are unit of time, or they indicates time. Okay, these are the special units, and you will get more special units in our study material, and the link for the study material is given under the description box. Now we can go into dimensional formula. Dimensional formula. Dimensional formula means the powers given to fundamental quantities or basic quantities to represent a physical quantity. Okay, the simplest for the first dimensional formula we have to study is dimensional formula of velocity or dimensional formula of speed. It is LT power minus 1. And what about dimensional formula of acceleration? LT power minus 2, because acceleration, unit of acceleration is meter per second square, so LT power minus 2. What is the dimensional formula of momentum, linear momentum? Linear momentum, mass into velocity, mLT power minus 1. And what is the dimensional formula of force? Force is mass into acceleration, mLT power minus 2. Dimensional formula of force. And next, what is dimensional formula of energy, or dimensional formula of work, or dimensional formula of torque? All are same, ml square t power minus 2, because torque is the simplest form. Equation for torque is R cross F, displacement into force, and work also force into displacement, F dot S. So dimensional formula of work is ml square t power minus 2. R cross F is R of sine theta, F dot S is Fs cos theta sine theta, etc. are trigonometric functions, and trigonometric functions do not have dimensions. And the sixth one, dimensional formula of density. Density possesses equation mass by volume. Mass dimensional formula m, volume is L cube. It will come on denominator, but while writing it on numerator it will be L power minus 3. mL power minus 3 is the dimensional formula of density. And what is dimensional formula of power? Dimensional formula of power is work, dimensional formula of work by time. Work dimensional formula here, ml square t power minus 2 by time. T will come on denominator, it will go to numerator with power minus 1. So the dimensional formula of power is ml square t power minus 3. And what is dimensional formula of power of optical device? Power of optical device, we have an equation, power equal to reciprocal of focal length simply for a mirror. Power equal to or for a lens, power equal to reciprocal of focal length. Focal length unit is meter, so power unit is meter power minus 1, or it is called diopter capital D. So dimensional formula of power of optical fiber is L power minus 1. And the ninth point. Ninth point is temperature. How can we write dimensional formula of temperature? Dimensional formula of temperature usually we write theta or we write K, capital K. K is Kelvin. So dimensional formula of temperature is written as theta or K. Don't write capital T in dimensional formula for temperature because capital T is reserved to represent time in dimensional formula. Okay, 10th one is angular displacement. Angular displacement symbol is theta. Angular displacement does not possess dimensional formula. Angle, its unit is radian. Supplementary quantities radian, steradian, they are supplementary units in SI system, and that quantities are solid angle and plane angle. They do not possess dimensional formula, but they possess unit. So angular displacement, they have no dimension, m power 0, l power 0, t power 0. And what is the dimensional formula of angular velocity? It is omega. Omega is theta by t, angular displacement by time, or d theta by dt. So radian per second. So dimensional formula is t power minus 1 only. Okay. And what about dimensional formula of angular acceleration? Its symbol is alpha. Angular acceleration unit is radian per second square. So it is t power minus 2. Dimensional formula of angular acceleration is t power minus 2. And next, dimensional formula of electric charge. Q. Dimensional formula of electric charge is AT, because current I equal to Q by T. So Q equal to current into T. For current we will write A, capital A or I, and for time capital T. So electric charge possesses dimensional formula of capital AT, and sorry, it is 12th one, and 13th one is universal gas constant, capital R. Universal gas constant, its value is 8.314 joule per mole per Kelvin. 8.314 joule per mole per Kelvin. For joule we will write ml square t power minus 2, and for temperature k power minus 1, and for mole we will write mol power minus 1, or you can write instead of mole capital N. So in dimension formula you can write n capital N power minus 1 or mol power minus 1 to represent amount of substance. But by studying all these 13 dimensional formulas, you can find dimensional formula of any quantity in higher secondary physics. For example, magnetic field. How to find dimensional formula of magnetic field suddenly? How to find dimensional formula of magnetic field suddenly? Think about the simplest equation of the magnetic field. What is the simplest equation of magnetic field? Lorentz force F equal to QVB sin theta. Sin theta does not possess dimensional formula. So F equal to force equal to QVP. So magnetic field B F by QV. F by QV. Force possesses dimensional formula mLt power minus 2 and charge on denominator AT and velocity LT power minus 1. L cancelled, T also cancelled. So we will get mt power minus 2 A power minus 1. This is the dimensional formula of magnetic field. So think about the simplest equation of the quantity. And another example, self-induction. Capital L, and the same dimensional formula for mutual induction too. Okay, what is the dimensional formula? How to find dimensional formula of self-induction? Self-induction, what is the simplest equation of self-induction? Magnetic flux phi equal to Li. Magnetic flux phi equal to Li. So L equal to phi by I. And for phi is the magnetic flux. Magnetic flux simplest equation is magnetic B A cos theta, B dot magnetic field dot area divided by current. Magnetic field we already found here. So you can see here ml square T power minus 2 A power minus 2. ml square T power minus 2 is dimensional formula of energy, work. That is joule, its unit is joule. Self-induction unit is Henry. So we can say 1 Henry equal to joule per ampere square. 1 Henry equal to joule per ampere square. So from the dimensional formula we can find the relation between units too. So 1 Henry equal to joule per ampere square, and joule is Newton meter. Joule is Newton meter. We can expand it like that too. Okay, and another one more example. How to find dimensional formula of coefficient of viscosity eta. What is the simplest equation containing eta, coefficient of viscosity? We studied that Stokes law, F equal to 6 pi eta RV, or some students studied 6 pi eta AV, whatever it may be, it is the radius of the sphere. So force F equal to 6 pi eta AV or RV. So from here ML T power minus 2 equal to 6 pi has no dimension, it is constant. Eta dimension that we have to calculate. Radius L, velocity LT power minus 1, LT power minus 1. 1 L will be cancelled. T power minus 1, T power minus 2 here. So this will become T power minus 1, and this L will come a denominator and it will go to the numerator with power minus 1. M L power minus 1 T power minus 1 is the dimensional formula of coefficient of viscosity. Okay, how to find dimensional formula of epsilon 0, epsilon naught. Epsilon naught, what is epsilon naught? Absolute permittivity of free space. What is the simplest equation containing epsilon naught? What is the simplest equation containing epsilon naught? We studied that Coulomb's law, F equal to K Q1 Q2 by R square. This K is 1 by 4 pi epsilon 0 Q1 Q2 by R square. For force we will write mL T is raised to minus 2. 1 by 4 pi has no dimension, 1 by dimension of epsilon 0 into for charge AT into AT divided by length L square. So we will get epsilon 0 will come here, dimension of epsilon 0 equal to A square T square divided by M L cube t power minus 2 on denominator, so we will get m power minus 1, l power minus 3, t power 4 a square. This is the dimensional formula of epsilon naught. So using the simplest equation of the quantity, we can find easily the dimensional formula of any physical quantities. And one more. What is the dimensional formula of magnetic permeability? What is the dimensional formula of magnetic permeability? Mu 0. How to find dimensional formula of magnetic permeability? Where we used magnetic permeability? Biot-Savart's law. dB, small amount of magnetic field, equal to mu 0 by 4 pi into IDL sin theta by r square. IDL sin theta by r square. dB is the small amount of magnetic field. What is magnetic field dimensional formula? M t power minus 2 a power minus 1. We just proved it just before. Or you can prove it F equal to Q from F equal to QVB. M t power minus 2 a power minus 1. Mu 0 by 4 pi has no mu 0 dimension. We have to calculate IDL sin theta for current A, DL small length L divided by radius distance square, so it is L square. So what will we get? L square will be L the, and this is ampere, this will come here. So dimensional formula of mu 0 equal to m t power minus 2, this L will go, so m L t power minus 2, m L t power minus 2, a power minus 2. This a will go to the denominator and will go to the numerator with power minus. So m L t raised to minus 2, a power minus 2. That is the dimensional formula of mu 0. That is the dimensional formula of mu 0. Okay. Like that, you can easily find dimensional formula of any physical quantity using their simplest equations suddenly. Okay, now we have to discuss what are the applications of dimensional formula. One application we already discussed, conversion of units from one system to another using equation n2 equal to n1 into m1 by m2 power a, l1 by l2 power b, and t1 by t2 power c. Okay, next application of dimensional analysis is to check how to check correctness of an equation, a relation in physics. Okay, to that we use a rule, a principle. That principle is called the principle of homogeneity. That principle is called the principle of homogeneity. This principle says a dimension of any term in a relation, must be the same. For example, when we are writing a relation a plus b minus cd plus root e equal to f, then according to principle of homogeneity, dimension of a should be equal to dimension of b, that should be equal to dimension of cd, that should be equal to dimension of root e. Root e we can write e raised to 1 by 2, that should be equal to dimension of f. This is what discussed by principle of homogeneity. A is a term, b is another term, cd is a term. Here c into d, multiplication is not the separation of a term. So plus, minus, equal to, etc. are the signs of separation of terms. So their dimension of each term must be the same according to principle of homogeneity. Okay, and now we can say one more point here. The point is, we have a relation A plus or A minus B. This relation is valid. This relation is valid only if dimension of A equal to dimension of B according to principle of homogeneity. Two quantities are added or subtracted or used equal to sign. Okay, these symbols are valid, or these operations are valid if dimensional formulas are same according to principle of homogeneity, because each term should have the same dimensional formula. If dimension of A is not equal to dimension of B, if dimension of A is not equal to dimension of B, then A plus B, A minus B, A equal to B, etc. are not valid, but A into B and A by B divisions are valid. Multiplication and division are valid algebraic operation if the dimensional formula of two quantities are unequal according to the principle of homogeneity. Okay, P plus A by V square into V minus B equal to constant. This is the van der Waals equation for real gas conditions. Okay, P is the pressure, V is volume. Okay, A and B are van der Waals constants. Okay, here is the question is how to find unit and dimension of A and how to find unit and dimension of B. That is the question. Okay. First we can find dimension of B from here according to principle of homogeneity. Dimension of B should be equal to dimension of V volume, because each term should have same dimensions according to the principle of homogeneity. Volume unit is meter cube and its dimension is L cube. So SI unit of B is meter cube. Okay, and now how to find unit and dimension of A? The first van der Waals constant A. How to find from here? Dimension of P equal to dimension of A by V square. Then dimension of A equal to pressure into volume square, dimension of PV square. Okay, pressure is, we know, force by area into volume square. Dimension of force is ml t power minus 2 and volume it is L cube volume square, so L cube whole square divided by area is L square. Then we will get dimensions ml t power minus 2 L power 6 into L power minus 2. This L square will go to the numerator with the negative power. So we will get L raised to 6, L raised to 7 and L raised to minus 2, we will get L raised to 5 t power minus 2. This is the dimensional formula of A. And what is the unit of A? SI unit of A is force unit is Newton, area meter square, or we can write Pascal here. Newton by meter square into volume square, it is meter cube square. So we will get Newton meter raised to 6 by meter square and Newton meter power 4. That is SI unit of A. So we can say SI unit of B is meter cube and SI unit of A is Newton meter power 4. Unit and dimension of van der Waals constant we can find using principle of homogeneity. Next application of dimensional analysis, how to derive relation between physical quantities. Okay, I am discussing that theory and explaining that concept using a question. Here is the question: if velocity v, acceleration a and force F are basic quantities, then dimensional formula of angular momentum is. Options are here: f a raised to minus 1, vf v cube a raised to minus 2, f v square a raised to minus 1, f square v square a raised to minus 1. How to find? We know that we are calculating dimensional formula of angular momentum in terms of force, velocity and acceleration. So we can say dimension of angular momentum, so we can take angular momentum depends on L proportional to force, velocity, acceleration. But we can't write this directly because we don't know force, how much force is affecting angular momentum. So we have to write F power x and velocity power y and acceleration power z. And this x, y, z we have to calculate, and that is the correct answer. That will be the right answer. So angular momentum L proportional to F power force power x, velocity power y and acceleration power z. Okay, now we are taking dimension of LHS. Dimension of LHS should be equal to dimension of RHS according to principle of homogeneity. Here equal to a constant into this, we can write L equal to a constant into f raised to x, v raised to y, a raised to z. Here this k is dimensionless constant. So no need of taking this k. Dimension of LHS, dimension of angular momentum should be equal to dimension of RHS, that is f raised to x, v raised to y, a raised to z. What is the dimension of angular momentum? Simple equation of angular momentum is mvr or r cross p. M is mass, velocity Lt power minus 1 and r is the radius. Okay, so it is L, so we will get ml square t power minus 1. Here we will get ml square t power minus 1 equal to force dimension is mlt power minus 2 whole power x. V velocity Lt power minus 1 whole power y, acceleration Lt power minus 2 whole power z. Now we just compare powers of mass, length and time on RHS and then on LHS. So here mass power is 1. So from here we will get 1 equal to here mass power x only. In both cases there is no mass. So 1 equal to x when comparing powers of mass. 1 equal to x. So f power 1 should come in answer. 3 options are there, A, B, C. So we have to take the next. Taking powers of L. Here you can say L power 2. 2 equal to here L power x, L power y, x plus y, L power z, x plus y plus z. 2 equal to x plus y plus z because L power x, y, z. So x is 1, right? So 2 equal to 1 plus y plus z. 1 will come here. 1 equal to y plus z. We will get a relation like this while substituting value of x. Now take powers of t. Here t power minus 1. Minus 1 equal to here t power minus 2 into x plus here t minus 1 into y, that is minus y, and here minus 2 into z plus minus 2z. So 1 equal to 2x plus y plus 2z. 1 equal to 2 into x is 1, so 2 plus y plus 2z. Okay, 2 will come here, or 2 will come here, then we will get minus 1 equal to y plus 2z. Equation number 2. By solving 1 and 2, we will get z and y. How to solve 1 and 2? Equation number 1 is Equation number 1 is 1 equal to y plus z. Equation number 2 is minus 1 equal to y plus 2z. So I am subtracting 1 minus 2 from 1. Then I can cancel y. Okay. 1 minus minus 1 is 2. 1 minus minus 1, it is 2. 2 equal to y minus y is 0. Z minus 2z is minus z. So I will get z equal to minus 2. Z equal to minus 2. Z on a power minus 2, f power 1. So according to the option B is the right answer. Then we can calculate y2 from equation number 1. In equation number 1, 1 equal to y plus what is z minus 2. So y equal to, we will get minus 2 will come here, y equal to 3. So option B is confirmed. Okay, this is the method how to calculate, how to derive relation between physical quantities using dimensional analysis. To solve this problem, you can apply one more method. Sometimes it will be easy and sometimes this method will be easy. What to do is, you just find dimensional formula of angular momentum and take each options and find the dimensions too. Which suits dimensional formula, which option suits dimensional formula of angular momentum, it will be the right answer. Okay, that is one more method. Okay, according to the question, sometimes the first method will be easy or the second method will be easy. Okay, checking the dimensions of options. Displacement in nth second is given by the equation. Next question. Displacement in nth second given by the equation Sn equal to u plus half a into 2n minus 1. Question is, what is the dimensional formula of Sn? What is the dimensional formula of Sn? Options are given as Lt power minus 1, L power 0, and option D is Lt power minus 2. Okay, what is the right answer according to principle of homogeneity? Sn is displacement, so is option A is right? No, option B is the right option. Why option B is right? According to principle of homogeneity, dimension of Sn should be equal to dimension of u. U is the initial velocity. So velocity dimension is Lt power minus 1. Velocity dimension is Lt power minus 1. So Sn is not actually the displacement. Sn is the displacement traveled by the body in nth second. Displacement traveled by the body in a particular time interval. Displacement in a particular time interval is actually its velocity. So Hn actually indicates speed or velocity of a body in a particular time interval. So dimension of Sn is Lt power minus 1 and its unities, and dimension of unities meter per second actually according to principle of homogeneity. So this equation is both numerically and dimensionally correct. This equation is both numerically and dimensionally correct. Why numerically correct? We are studying equations to solve numericals, right? We are studying this equation. We proved this equation in higher secondary 11th. So this equation is numerically correct. We are using this equation to solve numericals, and this is also dimensionally correct according to principle of homogeneity, because Sn is not only the displacement, Sn is the displacement traveled by the body in a particular time interval in nth second. Significant figures. Significant figures. 0.007. How many significant figures are there? Only one significant figure is in 0.007, according to physics NCERT textbook. Only one significant figure. Why? All non-zero digits are significant. Non-zero digits are significant. And the next rule is leading zeros are not significant. Leading zeros means zeros coming to the starting of the numbers, zeros coming to the starting of non-zero digits are not significant. So these three zeros are not significant. 7 is significant figure. And now 0.00700, how many significant figures are? 3 significant figures are here. Why 3 significant figures? Zeros to the right of a digit. Zeros to the right of a digit in a decimal number. In a decimal number is significant. This poses a decimal point. Zeros to the right of a non-zero digit containing a decimal position are significant figures. Here 3 significant figures are. Okay, now 5,000, how many significant figures are? Only one significant figure, because trailing zeros without decimal are not significant. Here trailing zeros or ending zeros with the decimal are significant. Here non-decimal position, so all trailing zeros are not significant. And now 3 into 10 power 8, how many significant figure? Only one significant figure. In exponential notation, only the numerical portion will denote significant figures. How significant figures are taken in mathematical operations? First we are discussing addition or subtraction. Okay. For example, when we are adding 9.823 plus 5.1, the result is 3, 2, 9, okay, here 4, 1, 14.923. The correct answer according to the rule of significant figures is 14.9 only. Why 14.9? According to the rule of significant figure, result of addition or subtraction should be with the least number of decimal position. Here 5.1, it poses only one decimal position, so the answer is 14.9. No need of writing 14.923. 14.9 is the right answer. Now next, 9.823 plus 5.232, you will get 0 here. 9 plus 5, 4, 1, 5, 15.023. What is the right answer here? It is 15.0 according to the rule of significant figure. Okay. The answer, result of addition or subtraction should be rounded off to the least decimal. While multiplying 142.06 with the 0.23, we will get the final answer 32.6738. What is the answer according to the rule of significant figure? 32.6738 is wrong. 33 is the right answer according to the rule of significant figures. Why? Result of multiplication or division should be rounded off to minimum number of significant figures. In here 142.06 poses 5 significant figures, 0.23 poses 2 significant figures, so answer should be with the 2 significant figure. But in addition or subtraction, answer should be with the minimum number of decimals. That is the difference. In multiplication or division, answer should be with the minimum number of significant figures. But here the rule is minimum number of significant figures. Here minimum number of decimals. Result should be with the minimum number of decimals. That both are the rules of significant figures. Next, least count, LC. What do you mean by least count? Least count is the minimum value that can be measured using a device. Minimum value that can be measured using a device. For example, using meter scale, least count is 1 millimeter. 1 millimeter is the least count of ordinary meter scale. 1 millimeter, it is 0.001 meter or 10 power minus 3 meter. While understanding the least count, we can identify the device. So least count is 0.001 meter, then the device should be meter scale. For Vernier calipers, normally least count is 0.1 millimeter, that is 0.001 meter or 10 power minus 4 meter. By using from the measurement, from the least count, we can identify the device. And for screw gauge, ordinary for a screw gauge is also called what? Micrometer screw. Screw gauge is also called micrometer screw. For ordinary screw gauge, least count is 0.001 millimeter, that is, it is 10 power minus 6 meter or 1 micrometer. 1 micrometer. So from the device we can understand, from the measurement we can understand the device, with which device the measurement is taken. For example, when someone writes length equal to 0.35 centimeter, length equal to 0.35 centimeter, which device is used for this measurement? How can we understand? 0.35 centimeter, we can write 0.35 into 10 power minus 2 meter. That means 3.5 into 10 power minus 3 meter. It is 3.5 millimeter. 3.5 millimeter. So its least count is 0.1 millimeter. Here 1 decimal. So 0.1 millimeter is the least count. 0.1 millimeter least count is possessed by Vernier calipers. So from the data given in the measurement, we have to understand the device used for the measurement. The device used for the measurement. Okay. As least count increases, we can say as least count increases. As least count decreases, accuracy in measurement increases. Error decreases. As least count decreases, accuracy increases, error decreases. Okay, now error in measurement. What is error? Error is the uncertainty in measurement. To calculate error, error is actually a difference between the true value and the measured value. Error is the difference between true value and measured value. Modulus of true value minus measured value. the value, measured value may be little bit greater than the true value or maybe little bit less than the true value. So that is the error, difference between true value and measured value. So value, we will write the value as the measured value, true value we will write. True value equal to measured value plus or minus error. True value we will write measured value plus or minus error. For example, resistance equal to 10 ohm plus or minus 0.1. 10 plus or minus, resistance are equal to 10 plus or minus 0.1 ohm. 10 is the measured value, 0.1 is the error. That means resistance may vary from 10 minus 0.1 ohm to 10 plus 0.1 ohm. That means resistance varies between 0.99 ohm to 10.1 ohm. From here, 0.1 ohm is the measure of uncertainty. It is called the error. Okay, next finding, least count error. Error associated with least count of the device. There is least count error. Error associated with the least count of the device. For example, length equal to 25 millimeter. Error is not given. So, what will be least count here? Least count will be 1 millimeter. Second point is 5. Okay, last point is 5. So, with this device, he can measure to 1 millimeter. Least count is 1 millimeter. So, here least count error is also 1 millimeter. It should be plus or minus 1. So, while writing length L correctly, length L equal to 25 plus or minus 1 millimeter. It is the correct notation when error is not directly given in question. Then we have to take least count error. That is, the least count is the minimum value that can be measured with the device. That least count is the maximum possible error. Least count is the maximum possible error in careful measurements. Okay, one more example. Current I equal to 1.256 ampere. What is least count here? Least count is 0.001 ampere or 10 power minus 3 ampere or 1 milliampere. It is the least count. What is least count error here? Least count error is also 1 milliampere plus or minus 1 milliampere. Okay, because it is the maximum possible error in careful measurements. Now, how to reduce errors in the measurement? How to reduce errors in the measurement? We will take large number of measurements. We will take large number of observations and their average is taken as the mean value. Mean value is taken as the true value. Let A1, A2, etc. AN are measured values. Then what is the true value? A bar or A mean equal to average A1 plus A2 plus etc. plus AN divided by N. This is taken as the true value. Average is taken as the true value. Okay, then what is absolute error here? Absolute error means we will take delta A. Delta A1 equal to true value, modulus of true value minus measured value. True value minus measured value. Absolute error in first measurement, delta A1 equal to true value minus measured value. We need only its magnitude. May be greater than the true value or maybe less than the true value A1. So we will take absolute error its magnitude only, delta A1, like that. Absolute error in nth measurement, delta An equal to, we can say, A bar minus An. This is the method to calculate absolute error, and their average is called mean absolute error, and their average is called mean absolute error, that is delta A bar, delta A1 plus delta A2 plus etc. plus delta An divided by n. Average of the error is called mean absolute error, and relative error or fractional error. Relative error or fractional error is equal to mean absolute error by true value. Mean absolute error by true value, and the percentage error is fractional error by fractional error into 100 is the percentage. Fractional or relative value, when it is multiplied with 100, we will get the percentage value. So this is the method to reduce random errors. Okay, but to reduce random errors, we have to observe the measurement. We have to take the measurement lot of times, and their average is taken as the true value. Their average is taken as the true value. Then when we are subtracting measurement from measurement in each time from the true value, then we will get errors in each measurement. That errors are called absolute error, and when they are taking their average, it is mean absolute error. It is mean absolute error, and that mean absolute error by true value gives the relative or fractional error, and multiplying with 100 we will get the percentage error. Now error in addition or subtraction. Error in addition or subtraction. If z equal to a plus or a minus b, if z equal to a plus or a minus b, then error in absolute error in z equal to error in a plus error in b. In addition or subtraction, errors are always added. Errors are always added. Okay, and to find percentage error in z, what we have to do? Delta z by z, error by true value, equal to what? Delta a plus delta b divided by a plus b or a minus b. What was the actual calculation that we have to take? Into 100. This is the percentage error in z. Okay, so in short, in addition or subtraction, errors are always added. Errors are always added. And what about in multiplication and division? In multiplication or division, if z equal to a into b or a by b, relative error in z equal to relative error in a plus relative error in b. Relative error in a plus relative error in b. That means in multiplication or division, relative errors are added, and in addition or subtraction, absolute errors are added always. Okay, that is the point. In multiplication or division, relative errors are added. In addition or subtraction, absolute errors are added. And if it is a powered quantity, for example, if z equal to a raised to n, Then what is relative error in Z? A raised to n means A comes n times. Multiplying A into A into A into A into like n times. So A repeats n times, right? So n into relative error in A. We are multiplying with the power n into relative error in A. So we can check an example here. A quantity Z equal to A B square C raised to 1 by 2 D raised to minus 2 divided by root F G raised to minus 1 G raised to minus 1. Then what is the relative error in Z? Can you do it? Can you say that? Can you say that equation? Delta Z by Z equal to delta A by A plus 2 into delta B by B plus half into delta C by C plus 2 into delta D by D. Why plus? Relative errors are always added. If it may be multiplication or division, relative errors are always added. Okay, not subtracted. So here power is minus 2, no need of thinking about the negative sign, plus 2 into relative error in D, delta D by D, plus half into delta F by F, because root F means F power 1 by 2, plus here also plus delta G by G. Errors are always added. Now we can go into a problem, a numerical question. Question: the resistance are equal to V by I, where V is voltage is 100 plus or minus 5 volt, current I is 10 plus or minus 0.2 ampere. What is the total error in R? Options are 5%, 7%, 5.2%, 5 by 2%. How to calculate? R equal to V by I. So delta R by R equal to delta V by V plus delta I by I. Okay. Percentage change is given in question, so we have to multiply with 100. Delta R by R into 100% means delta V by V. What is delta V? Delta V is the error in voltage. This is delta V. 5 by, what is original value? This is V, 100. 5 by 100 into 100. We are taking percentage change. So we have to multiply with 100. Plus, what is delta I? Error in current, it is 0.2 delta I, and 10 is the original current. So 0.2 by 10 into 100%. So we will get 100 cancelled, 5 plus 0.2 into 100 is 20 by 10 is 2, 5 plus 2%, that is 7%. So relative error means error by original. Okay, and they are added in multiplication or division. And one more example I am giving you. Length L equal to 1.00 meter. What is percentage error? Can you calculate? Length L equal to 1.00 meter. What is the percentage error? How can you calculate it? Here error is not directly given in question. Then what we have to take least count error. Here error is not directly given in question, so we have to take least count error. What is least count error? Least count is 0.01 meter. Two decimals are here, so 0.01 meter is the least count. This is the least count error. Least count and least count error both have the same value. You will put plus or minus. That's only the difference. So percentage error in length delta L by L into 100 equal to what is error? 0.01 by what is original length 1 into 100. So 0.01 into 100 by 1%. 1% is the percentage error in length here. If errors are not directly given, then we have to consider the least count error. Vernier calipers. Reading on vernier calipers are equal to MSR plus VSR into LC. What is MSR? Main scale reading. What is VSR? Vernier scale reading which coincides with any value of main scale, and LC is the least count. Least count of vernier caliper is 1 main scale division minus 1 vernier scale division. This is the least count. This is the method to find least count on vernier calipers. Okay. For example, if 10 vernier scale divisions match with 9 main scale divisions, 10 vernier scale divisions match with 9 main scale divisions, then we can say 10 VSD equal to 9 MSD. 1 VSD equal to 9 by 10 or 0.9 MSD. Normally 1 main scale division is 1 millimeter. The smallest division on main scale is 1 millimeter. So 1 vernier scale division we will get 0.9 millimeter. So least count LC equal to 1 millimeter, 1 MSD minus 0.9 millimeter, that is 1 VSD, that is 0.01 millimeter. Sorry, 0.1 millimeter. This is the least count of ordinary vernier calipers. 0.1 millimeter is the condition of ordinary vernier caliper. 10 vernier scale divisions will match with 9 main scale divisions. Micrometer screw, and when questions are coming about spherometer, then also you can use the equations of screw gauge. Reading on screw gauge are equal to main scale reading plus circular scale reading into least count. Main scale reading is pitch scale reading, circular scale reading is actually head scale reading, the circular scale, and least count. What is least count? Least count equal to pitch by n. What is n? Number of divisions on circular scale. N means number of divisions on divisions of circular scale. It is usually 100. Normally it is 100. Least count is pitch by n. Here pitch equal to distance moved by screw. Distance moved by screw by number of rotations. Distance moved by screw by number of rotations. When we are rotating the screw from 0, for example 10 rotations, after 10 rotations 4 millimeters moved on the main scale, then what is pitch? If 4 millimeter moves on the main scale after 10 rotations, this is as an example, after 10 rotations, if 4 millimeter movement on the main scale, then pitch equal to what? Pitch equal to 4 millimeter by 10, it is 0.4 millimeter. 0.4 millimeter. And what is least count then? Least count equal to pitch by number of divisions. Here 0.4 by Number of division is ordinary, it is 100, so we will get 0.004 millimeter, or we can write 4 into 10 raised to minus 6 meter, or 4 micrometer. 4 micrometer is the least count of this screw gauge. So screw gauge possesses least count around 1 micrometer. So screw gauges are also called micrometer screws. Okay. Now we have a question. Here is a question. The last question of the video lecture in the chapter Units and Measurement. This is the question asked in AIPMT, All India Medical Entrance 2018. AIPMT 2018. What is the question? A student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 millimeter and 0 on circular scale. CS indicates circular scale. MSR main scale reading. Okay. And 0 on circular scale coincides with 25 divisions above reference level. Then we got circular scale reading is 25. Okay. If screw gauge has 0 error of minus 0.004 centimeter, the correct diameter of the ball is. Our equation is reading equal to main scale reading plus circular scale reading into least count, and here 0 error is given as negative, so we have to add that value. We will write 0 correction because we are correcting it. So listen here. If 0 error is negative, it should be added to the measurement, and if 0 error is positive, it should be subtracted from the measurement. Once more, if 0 error is positive, it should be subtracted from the measurement. If 0 error is negative, it should be added to the measurement. So reading of screw gauge, main scale reading is 5 millimeter plus circular scale reading is 25. Least count is 0.001 centimeter plus 0 correction is 0.004 centimeter. So we will get 5 millimeter plus 20.025 centimeter plus 0.004 centimeter. Answer is in centimeter, right? So 5 millimeter is actually 0.5 centimeter plus 0.025 centimeter plus 0.004 centimeter. We will get 0.529 centimeter. Option 3 is the right answer. Option 3 is the right answer. Here you have to remember, in case of Vernier calipers and in case of screw gauge, if 0 error is given as negative, it should be added to the measurement, and if 0 error is positive, it should be subtracted from the measurement. Okay, the topic is over. Link of the study material is given in the comment box, and wait for the next chapter, motion in a straight line. Thank you. Best of luck.